So I'm going to start with this question here. I think it's a little difficult to read the screenshot, but it says a deck of cards contain red cards numbered 1, 2, 3, 4, 5, and blue cards 1, 2, 3, 4. So R is the event of drawing a red card. That's what they say. Let's write this out here in black. R means we draw a red card. That makes sense why they use R for that. So R stands for red. Any of these cards drawn, we'll say we have, it is event R if any of those cards are drawn. B is drawing a blue card. Again, B for blue. So if we have an event and any of these cards are drawn, we'll say event B has occurred. E is for even, so draw an even card. So in that case, it would be if any of these cards are drawn, the even numbers, we would say event E has occurred. And then the last one, O, is draw an odd card. O for odd. So what events would make O happen? It'd be drawing any of the odds, 1, 3, 5 red or 1 and 3 blue. If that happens, event O has occurred. And so the first question says you drew a blue 1. So we drew this card. Let's describe that using this terminology down here, these events and ands and ors and stuff like that. Well, it's not a red card, so we could describe this as this is something that occurs in not R, and that's a little symbol for not. So what has occurred? This is R, so everything else is not R. In this case, it's just the blue cards. So a blue card was drawn, so it was not R. That's one thing that one way we could describe drawing a blue 1. It's something not an R. It's also not even, so we could say it's not an even card. It is an odd card, so we could say it's O. I don't think that was one of the answer choices. You could say it's B. Individually, it is O. An odd card has been drawn. We could say it's B. I think one of the answer choices was an and, so saying like O and B has occurred, because that is true. O has occurred, it's odd. B has occurred, it's blue. So O and B has occurred. I'm trying to look at the screenshot really quick to see if what else they talk about, to make sure I'm covering all the answer choices that were part of this problem. Okay, so they got kind of complicated on here. There's a lot of different ways you could describe it with ors and ands and stuff. So these are the 4 things that have happened. It's not an R, it's not an even, it's not an even card, it's not red, not even, not red. It is odd, it is blue. So we can do that, and we could also mix and match these. So it's not even and it's blue. Okay, so kind of picking any 2 from this list, you could do an and with it. Just do one more. It's not red and it's odd. I kind of ran out of room there. I want to put O. Not red and odd. So then with the ors, you can mix and match from this list. As long as you have one thing on this list, the or is going to be true. So for an or probability to be true, you don't have to have both things being true. Like here, it's odd and blue. It's not even and blue. Those are both true. But with an or, it could be something like it's odd or it's red. Well, yes, that's one way to describe this card. It is either odd or red. It's odd. It fits the or. It's one or the other at least. All right, so again, that's going to be a lot of mixing and matching, but I think the start of a problem like this is to identify all the ways that you can describe this occurring. And then if you're using an and, it has to be both 2 things that are in in the circle here that describe what happened. And if it's an or, it has to have at least one thing from this circle that happened. So I hope that helps a little bit with this type of problem. I'll move on here to the next. This next one, binomial here. A recent baseball season, a guy named Ron was hit by a pitch 21 times in 602 plate appearances. So I have this written down here on my whiteboard, 21 divided by 602. That's what you would want to use a calculator for, to find the probability as a decimal, the percent of the time that he's hit by a pitch. So it's just over 3%. 21 divided by 602. That's the probability that you get hit by a pitch for Ron here. We're assuming that probability is the same in the playoffs. And it says in the first playoff series, Ron has 23 plate appearances. He's batting 23 times. What's the probability that Ron gets hit by a pitch exactly once? And it tells you for sure, use Excel to find this probability, round to 3 decimal spots. You definitely want to be using the spreadsheets for these. So the week 4 spreadsheet is what I'm going to pull up. It's all about binomial here. Let me zoom in a little bit. Binomial, easy calculations over here. How many times was the trial conducted? In this case, how many times was he at bat? We need to change that to our problem here. 23 times at bat. What's the probability that he gets hit on any given time? And it's always from that calculation. So that rounds up to 0.349. And I got that from the information in the problem, 21 out of 602. Yeah. And then what's the value we're looking for? And the problem says getting hit one time. So that's why I put a 1 in here. So out of the 23 trials, what's the chances you get hit one time? And we're looking for an exact equal to probability, getting hit exactly one time. I want to make sure that says yes. And so it'll x equals 1 is the probability I'm finding here. I can go ahead and put a no here just to make that other number disappear. We're not worried about getting hit more than one time, or less than one time, or at least one time. We're worried about, in this problem, it says, what are the chances Ron gets hit exactly one time? When that's the case, we do the equal to. And so there's a 36% chance as a decimal, 0.367. Excel did all that work, but based off of this probability of being hit, when you go up to bat, this is the probability that he gets hit exactly one time. I don't see the whole problem here, just kind of the answer described, but I think I can explain this working backwards. I think I understand it. We got a binomial situation where someone's typing in either the numbers 0 through 9 or the letters A through F. So that's 16 options. 10 numbers, 0 through 9, and then 6 letters A through F. And a success we're counting as a number. So there's 10 out of the 16 are numbers, 0 through 9. There's 10 options that are a number. 10 divided by 16 is 0.625. So if we're randomly picking from 0 to 9 and A through F, we have a 10 out of 16 chance of getting a number, or 0.625. So again, on this binomial, we're going to enter our probability as 0.625. That's our chances of success. I believe there's 32 times that we are conducting this experiment of picking from 0 through 9, A through F. So we're doing it 32 times, and a couple of ways to, well, what I think it's asking for, what's the chances you get 20 to 32 successes? So at least 20 successes. If you do it 32 times, what's the chances you get at least 20 successes? So not exactly equal to 20. I'm going to type no there. We don't want exactly 20. We want at least 20. I'm going to put a yes right there. Not less than 20, not more than 20, but including 20 or more. And so I want the yes right there. It gives me the probability that that would occur. I do this experiment 32 times, randomly pick something from that list. What percentage of the time, what's the probability I get 20 or more? And right here, that's how you would enter it. 20 out of 32, there's the probability. Put the yes, and then Excel pops it up for you right there. And yeah, I think that solves this problem. They're explaining how to do it a different way if you don't have this spreadsheet already set up. Like we have all the formulas set up here for at least, for less than, for more than, for at most. So their explanation was if you don't have all that set up already, kind of how to go about it. Uh, this is the easiest way to go about it. Having that spreadsheet is to type in 20, and then we're doing at least 20, so put a yes right there.